Good afternoon, everybody. Here we go again. And just like very short information. For those of you who wants to present something about their institution and possibility of exchanges, even if you don't have a presentation, but if you want to say a couple of words at the end of this very session, also from people online, please just tell me and we will find the way and time to do it. Thank you. So now I will leave the chair to Laura. Thank you, Laura.
Okay, so now we will continue with the oral presentations. First is Thais Ramirez from the Universidad of Costa Rica with exchange opportunities with the Paleolab UCR.
Thank you, Laura, and thank you everyone to be here. Thank you to the committee and Viviana for inviting me. Well, to start, Paleolab is a lab that belongs to a geology school, Central America Geology School. We have a collection, a fossil collection, and also we have some extraction areas where we work with some different kind of sediments and also with different groups of fossils. And it belongs to the paleobiology and sedimentology section, as Marco said before in the morning. Geology is on school, and paleobiology and sedimentology section is part of that school. Well, those are the researchers that work in the lab. First we have Viviana. You all know Viviana, and she works with foraminifera, and also Maria, that you look at her before. She is a radiologist. Also Waria Cárdenas, that she is the head of the school, and also she is a palynologist. But Pinchesnel, he is a sedimentologist. He is not here, but he worked with carbonate sediments. And there's me. I'm the lab manager. I have a licenciatura degree that is part of the study plans in geology in Costa Rica. Those are some of the students that work with us in the lab. Some of them are walking around here and helping us with the organization of this event. And they are doing their final project, in some cases thesis, and the other kind of projects that the program has. Those are some of the areas that we work in Paleolab. Something that is important to say is that we work two kinds of projects. We have investigation projects, and we also have social action projects. Like as Marco said before, it is a very important component of the education and investigation in the UCR. In investigation projects, we have topics related with paleobiological patrimony investigation, also with sedimentology, in marine sediments and also in continental sediments. And we also have paleobiology. And by the other side, in social action projects, we are starting with this project, with these two projects that I will talk to you later. But one is related with scientific dissemination, and the other one is related with paleobiological patrimony. I want to talk about a little bit of this one. This project is to support the patrimony investigation of biological patrimony, and also has the objective to maintain and conserve or help with that. In the collections, we have different kinds of collection. We have a microfossil collection and macrofossil collection, and also a recent collection. In the majority is mollusks, but we have other groups. And this is a screenshot of the Instagram page of the Paleolab. Okay, let's. I'm going to talk to you a little bit of the different study areas. We have around the country. We have different investigations. For example, those are not all that we have, but there are some examples, and maybe in the future can be an opportunity to come and work with us. We have this one about paleo reef ecology. It is in the northern part in Guanacaste province. Also, we have this one is about beach rocks in Costa Rica, and is located in the Caribbean and Pacific coast, all this part, as you can see. And also we have this one that works with carbonate platforms, is in the southern part of the country, in La Fila Costeña. Also, as you heard before, with Maria's presentation, we have these ones in the not the same in the Pacific coast, but we work with radiolarians, or Maria and her students. What we work with radiolarians in rocks and also in the deep sediments, as you heard before. And also there is another one here in the Caribbean coast that is developed by Viviana about foraminifera communities. But we also work with continental sediment. There's one, this picture is about a project that is developed in Guanacaste, in Amangares Basin. And it's about to study fluvial sediment and what is their provenance. We also have been working with palynology, or palynomorphs, in archaeological sites in the southern part. There is a museum, Finca 6. Maybe some of you have heard about it. And this another one is a starting project. Is from Laura. It's her thesis, and she will study all the crustaceans that are in the collection to try to identify them and have a better registration of them. Well, changing the subject, we have the Paleolab Social Action Project. I like very much this part. This one is called Geodivulgación. It's a starting project. Also, it's a brand new project. It started this year. That was a trail last year, and it is related to transmit the knowledge, the scientific knowledge, or knowledge related with geoscience, with the scholar kids or the community in general. depending of their needs. The other one is megafauna museum that is being developing in southern part in Cotobruz, San Vito de Cotobruz. In this project, we work with some Italian colleagues that came to visit last year, and they tried to identify the samples and the species to, in the future, try to create this museum in a local, it's a local museum, so it will be in a high school in that part of the country, in the south of the country. And those are some of our students, Diego, that is there, and Daniel, and those are the samples, as you can see. They have a very beautiful specimens. So the idea is in the future create that museum and the people can visit when they want. Other thing, changing again, we have some different methodologies that we work in the lab. We have that in the Paleo lab. We have the foraminifera. We can work with sediments to extract foraminifera, or we can work with rocks depending of the material. And this is part of the process. We usually try, we usually use some chemical reactives to treat them, and also after that we measure them, and then we look at it in the stereoscope or microscope, depending of the objective, and also it's allowed us to identify them and develop different kind of projects. The other important thing is that we have this extraction chapel that allows to work with strong acids. So it's very useful when we work with radiolarians or silicates groups. Those are some examples of the process. We treat them, then we sew them in the stereoscope, and finally we have these beautiful specimens. The other process, this is one of the hardest, I think, is to work with polynomorphs. In this case, we work with charcoal particles and also with pollen. Other thing that is important is that we have this cutting machine that was created here in the university, and it's very useful to cut cores, metallic cores, or even the plastic cores that for example, Mare and the equipment and the team recollect in the deep sea. Those are some examples of that course sampling. When we have then the samples like this one, we apply some reactives, and after in the case of the charcoal particles, we work with them in water. And in the pollen case, we work with glycerin and also with the microscope, biological microscope, to count the species. And to finish, we have these are our social media pages. I invite you to follow us. We have this Facebook page and this Instagram page. You can find us in those two social medias, and those are the contacts of the investigators. So you can contact us in case that you are interested in work in some of these areas. Thank you.
Thank you very much for the presentation. Does anyone have any questions?
Hello, nice. Thanks for the presentation. I have a question regarding the pollen. You show that you look to the pollen. I was wondering if that is with samples coming from marine sediments or more with lake sediments. Which sort of samples are you working for the pollen?
In the case of the pollen, we are just working with continental sediments, but I think we should find another polynomorphs, maybe marine polynomorphs. I think it's just looking for the methodology and try to do it.
No, but you could potentially find pollen also in the marine sediments.
I think yes.
Yeah, we have applied that very much in the Mediterranean and works very well because then you can compare changes in the ocean at the same time, the changes in the vegetation. So it has a very strong potential for trying to link ocean and. But it depends, of course, whether the pollen reaches the ocean and the area. But if you manage to find a nice course, it's interesting.
In fact, this project is in a deltaic system I forget the name. ¿Trabaja Laura? Yes, Terava. It's a deltaic system. So I think it should be in the marine sediments, or maybe in the shoreline sediments.
Thanks very much.
You're welcome.
Thanks, Thais. More than a question, this is an advertisement for anyone interested in collaborating with the identification of megafauna fossils. I know there are like lots of enthusiastic students, usually at the undergraduate level or probably at early graduate level. We have many available pieces sitting and waiting to be identified, classified, and put into a larger geological context in southern Costa Rica. So we're more than happy to welcome any researcher that has some interest in working in this part of the country. So there it is.
Thank you, Cesar. Yes, that's the idea, to exchange the knowledge.
Thank you, Thais, for your presentation. I was wondering, you said that you're working with strong acid. With which acid can you work? Can you work, for example, also with HF?
Yes.
You can? Wow.
Yes.
Whoa. Okay.
That chapel allows that.
Okay. Great. Okay.
Yes. Thank you. That was one of the areas that we want to work, because Maria worked with radiolarians, and sometimes they need to be treatment with HF. So the polynomorphs too. Yes.
Thank you, Thais, for a really nice presentation. I just wanted to add more of a comment. If you can use HF, then you'd also be able to do dinoflagellate cysts and non-pollen polynomorphs. So marine sediments wouldn't be a problem to get those critters out, because actually the preparation for them is much, well, I wouldn't say easier, but it's like similar to the pollen preparation.
Yes, yeah. I think all the groups that you need to use HF,
Yeah.
you can,
Yeah.
we can use, we can work with them.
Sounds
Yes.
good. Thank you.
Okay. Thank you very much. So
Thank
up
you.
next. So up next we have Mark First with the University Center in Svalbard with some exchange opportunities from there.
Thank you very much. Okay, let's see if it comes up. Yeah, so again, another little ice cube for your pina colada here, you know. So, just to give you, what I want to do is just give you an outline of what UNIS is, where it is, what kind of work we do, about the geology department there, and then what the opportunities would be for students and also researchers to come up there. And hopefully try to communicate that it's not necessarily that different in terms of some of the things that you guys do here in Costa Rica, that there could be some overlap. There we are, okay. So this is Svalbard up here. It's Norwegian. Here's Norway, there's the North Pole, so it is halfway between northern Norway and the North Pole. Really, it's actually closer to Greenland than Norway that we have. And it's quite an important place given its location on the edge of the Barents Sea. So we've got a big shelf sea area here, and then we've got this really important oceanic gateway between the North Atlantic and the Arctic Ocean through Fram Strait. Also being at a high latitude with the idea of polar amplification of climate change, it's a real kind of sentinel environment for both current and future climate change and previous climate excursions in the past as well. So it's very much well suited to that really strategic location. And really quite diverse geology with the central tertiary basin. We've got some very old basement rocks up in the north, and then we've got this zone of deformation along the west coast. So you can see both in terms of the rock types and the tectonic setting here in Svalbard, it's really quite a dynamic, interesting place, and continues to receive a lot of geologic exploration, because a lot of the rocks that outcrop here above sea level are the main oil producing and oil reservoir and gas reservoir rocks on the continental shelf. So it gives a snapshot into the geology there as well. So UNIS is the University Center in Svalbard. It's not actually a fully fledged university. It's a university center. It's a state-owned company owned by the Norwegian government and managed and overseen by the four main principal universities in Norway. Really, its mission is to provide Arctic-focused courses, Arctic-focused research, and enable students to come up there and provide that for the Norwegian institutions. But it's also an international institution. And really, it was built there strategically in the early 90s to be an alternative to the mining which was being phased out and tourism. So it's there's a strong geopolitical strategic reason for having the institution there as well. So students come up, they're based at their home institutions, whether that's Norway or internationally. They come up to UNIS and they take courses there and they receive credit for those which they can take back. We also have guest masters and guest PhDs who come up for some time for their research work. We also have PhDs in-house who complete their entire PhDs, but they also have to be registered at another institution to have their degree granted to them. So really that's the mission of UNIS, is to carry out really high quality research and education in a high Arctic polar setting. There is no equivalent institution like this anywhere else in the world, not even in Arctic North America, that provides that kind of in situ, real field-based education that we have. So we're really utilizing the local environment extensively for student training and for research in this area. We're a very small institution. We have 4 academic departments. We've got Arctic biology, geology, geophysics, and technology. As I said, very strong focus on field education, very diverse in terms of where students come from, and staff as well. So about 50% or so, it varies from year to year across the institution, are Norwegian, the rest are international, from other Scandinavian countries, from elsewhere in Europe, from North and South America. Actually, one of my colleagues doing his PhD is from Brazil. He moved his entire family to the Arctic. Took a bit of getting used to. We've got students from Singapore, from Hong Kong, from Australia and New Zealand in the past. One thing is that we have just over half female student group, obviously biology, but also in geology as well. And also all our instruction is in English, both at the PhD and master's level, but also at the bachelor's undergraduate level as well. So all the instruction is in English. Just to give you an overview of what life is like there, it's not just freezing in the dark. There's people bathing in ice-infested waters. There's a lot of opportunities to get out in the landscape, especially for students and staff as well. It's a really immersive experience to be there, as some of you know. So there's a lot of different things that's really centered on using the outdoors, both in terms of field work and recreating at the weekend as well. And this is actually one of the festivals we have. This is the Finnish component contingent having a sled race down the mountain. It's all kind of thematic. So the Finland sauna experience while sliding down the mountain. We have very good students. It's competitive entry to our courses, so we're selecting the best students in the world. And as a small community, there's only 2,500 people in Longyearbyen. Then those people quickly become integrated into the community. Just to give you some more background in terms of the way the university center is structured, that's the building there. We share that with the Norwegian Polar Institute and the Svalbard Museum on the same premises. We have about 70 people employed across those 4 departments and through administration and logistics. We've got about 25 PhD candidates, 9 postdocs across the institution, very internationalized as well, and really making up a sizable part of the community. So we're a major player in that small community. In terms of the departments, just to give you an overview, we've got our biology department, which has a both strong terrestrial and marine focus within UNIS. We've got Arctic geology, where we have both groups researching bedrock and structure in Svalbard. We've got more kind of physical geography, kind of process-based group, glaciology, permafrost, and then we've got the quaternary and marine group within the department there as well. Arctic geophysics is another strong department that we have. Very strong emphasis on meteorology and oceanography at UNIS within Arctic geophysics, and upper atmosphere research, especially researching the aurora borealis that we have there. And then Arctic technology, looking at the application of Arctic science to engineering and geohazard issues in high Arctic settings there too. In terms of marine research, we do have a small fleet of kind of inshore research vessels, which I'll talk about in a minute. But some of you have actually experienced some of these vessels through collaboration with the University of Tromsø, but also the Norwegian Polar Institute. A lot of our researchers and collaborators have access to the Kronprins Haakon, which is the Norwegian national research vessel, which is a full ice-class icebreaker that operates both in the Northern Hemisphere and in Antarctica as well. But also the smaller but ocean-going research vessel, the Helma Hansen. So these vessels have a full coring suite, so we can take piston and gravity cores, and full physical suite, but also CTDs and rosettes for water sampling, and kind of trawls and dredges for biological research. So these are our two platforms that through UNIS and our collaborations we have access to as well. Very strong emphasis on safety. Since the early 90s, given what we do and the high risk associated with working in the Arctic environments, snowmobiling, avalanches, crossing sea ice, we've actually never had anybody die on our courses. And that is in part due to the safety training they receive. The students receive very in-depth safety training. They actually receive firearms training, so they can actually sign out rifles for polar bear protection. You can't go outside of town without carrying a gun because of polar bears. It probably has the highest gun ownership in the world, maybe parts of the US, maybe higher, but we have no gun crime. So, we also have lots of facilities to support research. We have these inshore research vessels, these high-speed boats that we use to access field sites. We also have a small inshore research vessel, and then we have all sorts of snow-going equipment and snowmobiles, and a lot of safety equipment that's provided in-house to support our teaching and research. Within the geology department, we also have a lot of facilities such as very extensive shallow marine and lake coring facilities. We've got about 7 different coring modalities that we can use. We can do basic grain size and sedimentary analysis. We have lots of microscopy kind of facilities available as well. We also have some portable multi and single beam bathymetric equipment that we can mount on different vessels. We can do geochemical and water analysis. We also have extensive drone technologies. We have a lot of drones and a big lab that we can use to process that for structure from motion and also virtual reality, which is a big thing now for virtual reality teaching, especially during the dark season when we can't actually see the geology. So I would actually check out this site if you can and make some really beautiful aerial views, 3-dimensional views of Svalbard if you're interested. So just Google VR Svalbard. In terms of opportunities for students, as well as coming up to take courses, and students can register for courses from anywhere in the world and take their credits back to their home institution. And if you're from the European Union, that is actually, there's no, well, there's a 60 euro fee for that. There are different fees for those coming from outside the European Economic Area, however. But students can do that for guest masters and PhDs, though. Students can come up and undertake several months of research and be hosted at UNIS pretty much free of charge, aside from paying for their accommodation. And as long as they can have a supervisor at UNIS, they can come up there for ideally about a 3-month period or longer for their PhD work or for their master's work. So there's a lot of opportunity for collaboration with supervising students to work at UNIS in Svalbard. There's multiple deadlines for application through the year for that. And that's all on the UNIS webpage. The actual specific page for that is very, very long, so I haven't put it up there, but a quick Google search would find that. In terms of funding, for small kind of funding pots, such as what a guest master student might access, the Arctic Field Grant is one of the main sources of funding. That unfortunately has a deadline once a year in December 15, which can be a bit tight with defining projects. But that gives you up to about 10,500 euros to be able to support your fieldwork as a guest master or guest PhD student, or as a postdoc as well. It is open to everyone, but priority is given to students and early career researchers. And that there is from the Svalbard Science Forum, administered through the Research Council of Norway. Another one, which is only open to, as PIs at least, Norwegian-based researchers, but gives the opportunity for significant collaboration internationally, is the Svalbard Strategic Grant, which is also administered through the Svalbard Science Forum and the Research Council of Norway. That's also worth checking out for collaborative initiatives. Another opportunity is, I think we've already touched on this with other groups, is Erasmus+, both for students coming up, but also for staff. So there's opportunities for exchanges and collaboration through Erasmus, which is worth checking out as well. And then there is the Research Council of Norway, Forskningsrådet, which has a range of different open call and specific thematic grants. These are great if you can get them, but they have about a 5% success rate. It's highly, highly competitive. But this is one of the main funding agencies within the Norwegian system. There's a lot of opportunities for collaboration within those as well. And then lastly, we have this one I just discovered the other day. That's another potential possible funding through the Norwegian Agency for Development and Cooperation that is specifically targeting countries outside of Europe, which could be a possibility there. So my time is up. Thank you very much for your attention, and any questions on that?
Yeah, my question is more a curiosity. How do you reach the Svalbard? Like there is a airport or something like that?
Yes, I was going to say something flippant about getting on a whaling ship, but yeah. No, it's very, very well connected. There's a big international airport, well, international quality airport there. There are direct flights from Oslo and Tromsø. It's a 3-hour flight to Oslo, so staging through Oslo is probably the easiest way to get there. Compared to other similar kind of logistic hubs, say in Arctic Canada, it's far cheaper and easier to get to Svalbard than it would be to, say, somewhere like Resolute Bay in Canada. Yeah. And I would love to see you all there. Extend a welcome to collaborate and come and visit. So.
I already know Unis, so I just wanted to comment. If any one of you is looking for a PhD or is or knows someone who is, if you go to the Unis website, there's I think it's under job opportunities, is it, or open positions? At the moment, there's I think at least 2 geology PhD positions open. One of which is in paleoceanography with me. So, so just wanted to say that.
And also, we've just had our kind of structural and sedimentary geologist leave, and probably within the next 12 to 24 months, we may be advertising that position as well. So that could be coming up. Yeah.
Thank you. You say that you can have PhD student with an advisor in another university. Is this correct? So the PhD student has to have the fellowship from the university of the other university, not from UNIS.
Yes, so there's 2 ways for PhDs to be there. One is to have their full PhD project at UNIS, and that is funded through UNIS. They would still have to be registered at another institution to have their degree granted. So basically, they would have at least 2 supervisors, their UNIS supervisor and their home supervisor. Another way is for them to come for a shorter period to do their research work, perhaps as part of their project, and we can host them for several months, and they can come and stay there. They would still need a kind of
internal supervisor from UNIS.
They would, you know, but that's much easier to do. I've served that role with students who've been doing something very close to what I've been doing, and also with students who they've known a lot more than I do about what they're doing. But I've kind of facilitated that, you know, in agreement with the supervisor back at their hosting institution.
Thank you.
Yeah. Yeah.
Okay, so next we have Kimberly Garcia Mendez from the Smithsonian Tropical Research Institute. Kimberly Garcia is lab manager in ODEA's lab at Smithsonian Tropical Research Institute in Panama. She has been working on the systematics and taxonomy of mollusks with particular interest in sea slugs and nudibranch. She uses traditional and molecular approaches to reveal the diversity and evolutionary relationships of these charismatic organisms. Her interest is linked with the question of how marine species originate and underlying mechanisms of their evolution. She believes that science should be accessible for all members of the society and a safe place for stimulate our curiosity and creativity.
Thank you so much. Oh, okay. So I'm gonna try to avoid the ja sign. So thank you, everyone. Thank you for organizing this platform. It's a pleasure to be here sharing the opportunities that we have at Stride, specifically at the ODS Lab in Panama. So I'm gonna give you like a brief introduction just to make sure that you understand why the Stride is located in Panama and the kind of research that we do, and specifically in the lab, and also some of the research opportunities that you can access in the region. So, that's it, okay. Okay, so as I said, in order to understand why the Smithsonian is in Panama, basically has a presence over than 100 years, we gotta go back in time and we gotta basically understand the genesis of the Isthmus of Panama. So it's what we like to call this natural experiment in which we have two land masses. They were not connected, South America and North America, and we have this single water mass, and we have free flow of genes. The populations went from one side to another, and basically it was a very dynamic environment. So around like 3 million years ago, the isthmus it acquires a current shape, if you want to say it in that way, and something big happened. So basically, we have this bridge. Basically creates two main processes in terms of the biological populations. One was the Great American Biotic Interchange that connected the fauna and flora from South America and North America, but also this bridge isolates the populations from one side to another. So it creates, in terms of evolution and ecology process, it creates a really nice set of conditions to study and ask questions related to biology and ecology. Furthermore, if we look the consequences in both sides of the isthmus, we have two different systems to study. One side we have the Caribbean with these like a low productivity, high diversity, relatively stable conditions for the flora and fauna in this side. I'm talking about the water, of course. And in this side, in the tropical Eastern Pacific, we have this highly variable and high productivity environment. So because of this, we have not only in terms of biology and geology, cool setup of conditions to ask questions, but also in terms of oceanographic, it brings a lot of chances to study life and the interaction with these all different processes. So as I said, the Isthmus of Panama is a very unique system that provides a chance to explore the interaction of geology, evolutionary processes, and ecological process in a very convenient location. So, however, we have these sets of circumstances called the natural experiment. However, now we have this non-natural experiment called the Panama Canal. And I'm talking about this because the presence of the Smithsonian is related to this non-natural experiment. So as you probably know, the Panama Canal is the main source of economics in the country. Furthermore, it creates these new sets of conditions, for example, invasive species, populations that were not connected, now are they connected? So it brings these
chance to explore what happened or how was the past in terms of populations dynamics, for example, but also to ask questions regarding climate change, invasive species, and so on. And as I said, the Smithsonian basically came to Panama more than 100 years ago. While the US was really busy building the Panama Canal, a group of scientists approached the director of the Smithsonian in Washington at that time to basically to come to Panama with three main objectives. The first one was to compare the flora and fauna from South America, in North America, and comparing what kind of representation of these groups were in the Panama before the Panama Canal was built. As well, they were looking for compare what was in the Pacific and in the Caribbean. And in the meantime, they were trying to collect data about the flora and fauna on the area that the canal was basically being built. So over the years, the presence of the Smithsonian was only in Barra Colorado Island. Oh, sorry. Oh, I think I made the same mistake. I don't know. Okay, cool. I got it. Okay. So at the very beginning, they were located in Barra Colorado Island, basically, but because of the good results and the great data set that we're collecting, the Panama government allowed them to expand their operations in Panama. Over the years, many more people were coming down to Panama and established in the Smithsonian, that in the 1966, it was formally named as a Smithsonian Tropical Research Institute. So basically the mission of the Smithsonian is increase and the diffusion of knowledge of past, present, future of tropical biodiversity and its impact in this relationship with the human welfare. The current platform that we have now in Panama comprises, well, as I said, more than 100 years of presence in the isthmus, but also almost more than 400 staff that are working in 13 different facilities throughout Panama. So these 13 facilities, as you can see here, provides access to different environments, not only in the Pacific side, but also in the Caribbean side. And even we have Barra Colorado that is basically in the Panama Canal, but also we have representation in the forest over here, that is the Fortuna Forest Reserve. And also the most recent one is in Coivita Island, which is part of the Coiba National Park. So as you can see, we are scattered through Panama, and the access to facilities in very isolated places bring advantages to develop research in the area. I'm just gonna go over real quick the main buildings in case that you want to know what happened there. If you come to Panama, probably you're gonna be dealing with lots of administration situations, believe me. But here, the people that work here, they're the most helpful people because they're gonna help you with the permits, with the registration. You can also find here tools for your research, microscopes, labs, and basically this is the headquarters of the Smithsonian in Panama. As I said, Barra Colorado is one of the world's most studied tropical environments in the world. Actually, last year was 100 years anniversary for this station. And we have long-term experiments here, and the data set of climate and also tropical forest experiments here are really good, and they're available for all the people. One of the most recent is the Gamboa Research Facility. This is by really close, literally to the side of the Panama Canal. And here, pretty much the people that work here work with biology and land. The bats over there is the hub for this kind of research. And in my case, for example, I work here. This is like the access that the Smithsonian has to the Pacific coast of Panama. Here in NAU's Marine and Molecular Laboratories, we have access to an infrastructure that provides different types of labs. We have here our collection, in the case of the UDIA lab, our collection, basically the infrastructure to do basic processes with the samples. But also, in this side, we have, as I said, the boats of the vessels to do research in different areas of the Pacific. So we have, if I don't mistake, we had around 4 vessels of 5 that are available with different capacities to go to different sites in the Gulf of Panama. Punta Culera is one of the marine education centers that we have. This one, is it 5? I think it was 30. Oh, it's okay, it's okay. I was like, oh my goodness. Okay, so Punta Culebra is one of the marine education centers that we have. And basically here you can find, you can visit and know more about the research that the Smithsonian has in the area. Just to go this side of the Pacific and finish with that part, Isla Coibita is the last recent addition to the buildings that we have in Panama. This one is located in Coiba National Park, and the cool thing about this one is like you have to get off the bed and jump in the water in this very isolated place that is one of the most diverse places and really healthy, relatively healthy places in the tropical Eastern Pacific. Okay, so now to the Caribbean. We have 2 main facilities, the Caribbean Marine Laboratory in Punta Galeta, that is located in Isla Colón and is around I will say less than 2 hours, more than 1 hour from the city. So it's in a very convenient location. And in Boca del Toro Research, that is in the province of Boca del Toro, and you can have access here to different environments, not only coral reef, but also mangroves, lagoons, seagrasses beds. So it's one of the most well-equipped facilities that the Smithsonian has currently. Okay. Also, we have the public programs that are scattered along Panama, and with this is pretty much we use this as a platform to disseminate the knowledge that we produce at the institution. So, as I said, this slide basically reflects the diversity of topics that we work on. In my case, we work in paleontology and paleobiology, and I'm just going to give you an example of the research that we do there. So this project is 38 years ago it started. Basically, is the famous Panama Paleontologic project, and the goal was to bring this multidisciplinary group of scientists to collect samples and basically to use the rich geological records and story of Panama to understand how this story affects the life histories of the species in the region. So as you can see, the Gatunian province covered all this area. So the main goal was to collect samples from that area, and as you can see, we have modern sites and fossil sites, and a bunch of samples that basically they're still being processed. As you can see, we have samples from different parts of the Caribbean, but also from Central America, including Costa Rica, and some locations in South America. As I said, the samples are accessible. We're still working on those samples, and papers are published based on the data of these samples, but for some groups, for example, we don't have experts. So that's why it's important for you to understand if you want to approach us, basically, this is one of the primary sources of data that maybe you can contribute, and if you are interested, you're more than welcome to check. I'm going to talk about my lab. Just a little bit of water. As I said, well, I work for Gildea's lab. This is, as you can see, a very diverse group of people. So even though we have like 3 staff, we have postdocs, fellows, interns that come from different parts of the world. And it's a very dynamic lab, so sometimes people come from 3 months. And we have one of the postdocs, she came to the lab 10 years ago as an intern, and then she develops all the research, and now she's developing her postdoc project with us because she was like really interested in the area, and she's been contributing a lot with the work that we do in the lab. So if you ask me what kind of questions we try to answer in our lab, we try to look for those changes in the environment, basically using the fossil record. However, if you go outside, and I think we saw it yesterday in one of the talks from this morning, what we think that is pristine sometimes is not as pristine as we think, right? So what is a pristine environment and where is it? It's like we still can find some sort of places that are basically not affected by human impact. And this is because if we want to look the changes, if we want to basically interpret the changes on the communities, sometimes we work with the things that we can find, you know? And because of that, maybe that could be like obscuring our perception of the ecological and evolutionary processes. So as I said yesterday, Beatriz, she showed some examples of the trash that you can find in deep sea water. This one is one of the photos of the Everest that is like full of trash. So even though you think of an isolated places, the human impact is there. And if we're studying the system, maybe this could be some sort of like obscuring the kind of conclusions that we make, or we get in terms of ecology and evolution. So, because we're looking for to understand how life on Earth changed over time, we're looking for those pristine environments. But of course, we can just go and jump in the time machine and go back in the time, right? So we use the past records to reconstruct the natural and non-altered environments, basically before the human intervention. So the idea is to understand those ecological and evolutionary processes behind those changes. As I said, we use the fossil record to travel back in time, and we apply different methodologies. And one is like basically we go to this beautiful coral reef that this one is from Dominican Republic, if I don't mistake. We collect the bulk samples. We also do some of the reef matrix cores to access to samples on the coral reef properly. But also we integrate the archaeological data from the middens. So as I said, this one, by just going there, we can access to these 8,000 years old Caribbean coral reef. And we can collect the samples that are there. One of the techniques that we applied a lot in the lab is also the coral reef matrix. And basically what we do, I'm gonna show you a video, but what we do is basically hammer this long pipe in the coral reef to access to that record along inside the coral reef, sorry. So this one is just a quick video to show you what we do in this technique. This one is powered man and powered woman method. So basically we have to go there, and in this case we're doing that with scuba tanks. Sometimes depending on the conditions we do free diving. So, and also if you're working in the Pacific, it's easier because you can work around the tides. So sometimes you will see how you just coring, take a break, and the pipe just emerge because of the tide changing, you know? So we get the pipe. The hardest part, in my opinion, is to actually pull out the core out of the water. It's really hard. So once we get the core, I'm just gonna go back a little bit. But yeah. Once we have the core, we slice the core, and what we do is to keep 1/2 for the analysis and 1/2 for the collection, just to keep it as a testigo of witness. So, as a reference. So far we have more than 100 reef matrix cores to document the millennial scale changes in the Pacific and in the Caribbean. What we do with these slices is basically to try to understand the history of the coral reef in the Isthmus of Panama. So we basically took section of 5 centimeters and we analyzed those sections. We date those sections following the standard methodology, washing the samples, processing the samples. We are able to extract different representations in terms of taxa. So, for example, corals, mollusks, some algae. That's because we have also otoliths. We work a lot with otoliths, forams, and some other microorganisms that we can find. And these one from the corner are the shark denticles. That there is one of the postdocs. She's working with this topic, and she's been able to find really cool data regarding the shark populations in the past and in the present. So since we're getting this information from the past, we need something to compare it with. So we also collect like modern bulk samples, and also we do some sampling using nets or basically other methods to collect modern data. I'm going to show you one of the examples that recent examples of the research that we're getting, the results. So one of the questions that we're working currently is to describe how was the trophic structure of Caribbean coral reef before the selective removal of predatory fishes. So since we don't have record properly, we don't have numbers, abundances, so we have to use the fossils to go back in time. So as I said, we work with shark dermal denticles and with otoliths. So we have Brigida de Gracia. She is one of the experts of otoliths in the region. She's Panamanian. She's a Nobel Bouglé woman that she knows a lot about everything. But her specialty is basically the reef, the otoliths reef fish. And Erin Dillon, that she works with the shark dermal denticles. With the otoliths that we extract from the cores, we're able to identify, to describe or get an idea of the diet, the trophic level of that organisms, and also the body size. So you can see the kind of data you can generate with these fossils. With the dermal denticles of the sharks, they're really, really tiny, really tiny. So those are similar to like scale-like structures that the sharks shed, and they go to the bottom in the reef, and after depositing, after sink on the reef, they basically stay on the sediments. And by doing cores, we're able to find them, and we pair that information with the dating that we get from corals. So as I said, Erin, she's been able to get some cool data. Basically, she found that in the Mid-Holocene, it was 33% more sharks in the past than the ones that we can find now. And because we're able to identify what kind of functional group, the functional group of the denticles, we can assign them to specific groups of sharks. So for example, in the past, this type of sharks, more pelagic, were more abundant than the ones that we have currently, where this kind of functional groups like nurse sharks that are more like at the bottom. So it's been a change in the fauna. So by integrating this information, we're allowed to interpret the predator community with shark abundances. So as you can see, in the past, we have more sharks in relation with the modern samples. Also, looking by or using the otoliths to get information, we are able to also get more information about the abundances. So now we have less fish abundances than in the past. The body size also has changed over the past, so indicating there's been like an extraction pretty much because of, most likely for human activity. Also, we integrate the archaeological and modern samples, and we see that what humans were getting in the past, it was a difference in terms of size. This is for the snappers and for the grunts. So basically, we have that older fish, the prey community, also experience changes. And as you can see, the plantigrade fishes, we have a shift in terms of abundance and body size. Basically, what we found is that fewer and smaller predators are present today, while more and larger prey are present today. So just to recap what I just said, we were able to detect that this is a specific change in the communities. So that could indicate and evidence that the trophic dynamics have changed over the last millennium. So basically in the lab we use the fossils as a time machine, and also we do modern samples. This is pretty much a representation of what we do in the lab. But also we have a really important component that is the science communication, and I really want to, this was one of the hunting fossil trips that we have last year. 50 people, came to fossil hunting with us, and it was great to have kids, parents, learning about fossils. Because one thing in Panama is like when they visit us, they love dinosaurs, they love T-Rex, it's like, oh, but you know in Panama, you can find fossils, and they're thinking T-Rex, which is okay. However, because of the history of the region, we have so many fossils that are not necessarily T-Rex fossils. So when we took this group, everybody was like finding shark teeth, otoliths, what else? Oh, they found I don't remember the word in English, crocodile tooth. They were finding lots of things, and it was really nice because I think this is part of the responsibility that we have as a scientist. We know that we can find these animals here, this representation, but some people, they don't know. And the cool thing is like, we coupled these visits in the lab with also the project of the book that Aaron, my PI, wrote with one of the members of the lab. This is called Martina and the Bridge of Time. And the cool story here is that normally you learn at school the story of your country, the history of your country, but it starts from when the Europeans arrived to America. But before of that, it was a bunch of information. It was people living here, but if you go back in time, you will find information that these giant sloths were living in this area, these cool processes in terms of biotic interchanges were happening, and most people don't know about that. So Martina is a girl that she was eager to learn more about the history of Panama and the Isthmus. And in this book, she is able to travel back in time. And we basically, it's an invitation for the kids and also adults, of course, to learn more about the history of Panama. Okay, so and just to, I have like 1 minute. Okay, so just to go over the research opportunities, now that you know what kind of research we do. At Strive, we have different academic programs. We have the fellowships. You can be an intern, but also you can come as a, using the research platform for 2 days, up to months if you want. So for example, one of the most important programs is the fellowships. With these, we have, if I don't mistake right now, we have like 4 or 5 different programs or like subcategories of these fellowships. Some of them are for postdocs, some of them are for pre-doctoral students. And it can be like you're allowed to do research there for like up to 3 months, up to 3 years, which is one of the opportunities that the Smithsonian offers every year. Also the internships, she's Erin Dillon. She's the postdoc that came for 3 months in our lab, but she stayed. And this year is gonna be like 10 years since she arrived to Panama. And with the internships, we have 2 calls in a year, in February and September, if I don't mistake. But basically, that gives you the chance to the student to work for 3 months at the Smithsonian and get involved with the research, the ongoing research. And many students use this opportunity to develop part of the thesis project as an undergrads or as initiating just the masters, for example. One thing that I forgot to mention at the very beginning is that in order to have these research and these people coming from all over the place, the Smithsonian provides support in terms of data. So for example, the physical monitoring program is been going on since several decades, and the data is available, is open source for the people that need to check and get information from there. But also, if you field work involves scuba diving, we have the scientific diving program, and that gives you the chance to go to the field, diving, following the safety rules that it involves, of course. Basically, just to finalize here, the idea is to promote collaboration and networking. So this is very important. As you can see, we have 400 staff people in Panama, but more than 1,000 people visiting every year. So it's a very dynamic environment, and we look forward for collaborations and networking. You can consider part of international research community. You have people from all over the world, and it's never boring, de verdad. Basically, one thing that you can get from the Smithsonian is the training to pursue your professional objectives. I think it's a platform that is available for everyone, and we embrace people from all over the place. And if you're Latin American, that would be really great. We're trying to get more opportunities for places, for people that comes from places that is difficult to access to some specific platforms. So you're more than welcome to reach out, to ask for opportunities. And the idea here is just to take advantage of the platform and also of the opportunities that are available. So yeah, so just let me know. We're here to help you if you need, if you have a question and a specific question related to program, just let me know. It's gonna be a pleasure to have you. If you are in Panama, you can come and visit our lab. I'm gonna show you some fossils, no T-Rex, but for sure you're gonna see some cool stuff that we have there. So yeah, so feel free to reach out and let me know if you have questions. We can talk later. And thank you so much for your attention.
Okay, so does anyone have any questions?
Thank you, Kimberly. It was very interesting. And I have two questions actually. The first one regarding the work that you did with the coral coring and the those. Did you do also like paleoclimatic reconstruction with the paleoclimatic proxies, like I don't know, biomarkers or stuff like that? And the second one is more venial, I guess. Is the funding for, like, the fellowship has some fund, so the funding for the fellowship is provided by the institute, or you have to? Yeah. To skip taxes also. Thank you.
Thanks very much for very, very interesting talk. I really enjoy your example showing how you look into the record. You can compare the current ecosystem with the past one. It was really beautiful example. But I was wondering, one of always the deals comparing current data with past one is also the preservation issues. So I was wondering how you have approached it and how much are you sure that there is no any preservation artifact on that? Okay, thanks very much.
Thank you, Kimberly, for this very nice presentation. I was wondering, you said there are a lot of samples, specimens that can be studied, that are waiting to be studied. I was wondering whether there is a website where we can check those. Thank you.
Oh, sorry. También hablo muy duro. So far, they're available. So if you're looking for a specific organisms of a specific group, the best way to do it is contact Aaron O'Day or me and in this case to me as well. And we have the data and we can share the data with you. You're welcome.
Thank you. So up next, we have Anna Pinkowski from the UNIS and also from the Adam Mickiewicz University, also with some exchange opportunities.
Okay, yes. So I'm at two universities, but today I'll be speaking with my AMU hat on, Adam Mickiewicz University. If you're wondering who the heck is Adam Mickiewicz, it's Poland's greatest poet, okay? On a par with Goethe. I will give you an introduction or a brief outline of what kind of funding opportunities and exchange opportunities exist at many different levels. If you want to come and see us in Poznań, lovely city, I will have one slide dedicated to why it's such a nice place. And here you can see a picture of the old square. It's right in the center. It's a really lovely place. If you're wondering where is Poznań, where in the world is Poznań, it's right in the heart of Europe. And if we go to Poland, we have a look at Poland here, it's right in the middle between Warsaw and Berlin. Okay, so it takes about 2.5 hours to either. It's kind of strategically placed and it's got very good connections to the whole of Europe. It's not by the sea, but then neither is Pisa, and that's a great city too. So, you know, there's advantages and disadvantages. Okay, so in terms of funding bodies, if we look at the Polish funding landscape, we have several funding bodies, but probably the most important one is the National Science Center Poland. And that really provides the bulk of the funding that we get in terms of research funding, in terms of scientific research at Polish institutions. And within that, they've got calls for individual researchers and research teams, both national and international level. And there you have the whole kind of palette from a PhD level up through to postdoc and more senior researchers. So if you're interested in that, you can check it out in terms of the website and all the different grants. You can see that how many there are. There's actually quite a lot of them, and the success rate is pretty good. So nowhere near the abysmal Norwegian funding landscape with 5%, but it's probably more in the like 20 to 25%. Now, out of all of these, they may be of interest. I want to just draw your attention to this here, Polonez Biz, which is a fellowship program, which it runs through to 2026. That may be of interest. It's more for early career researchers and kind of postdoc level, but may be of interest to you. The conditions for these grants is that you be employed at a Polish institutions, at least for 50% in terms of the, so at least part-time, at least half-time. But with any of these, usually you can write in your own salary. So they're, I think, quite generous in terms of that. In terms of international programs, there's the National Science Center has specific dedicated international programs. On the one hand, this is cooperation with countries like Iceland, Liechtenstein, and Norway. There's specific programs, but not just. So I've just put this slide up here for you to see that there's many different international programs, and obviously there's different calls at different times of the year and so on, but there are opportunities out there. Another funding body that may be of interest, especially when we're talking about exchange, is NAWA, which is the Polish National Agency for Academic Exchange. And there actually we have a specific category for foreign students. So if you have any students that, for instance, want to come and visit, for instance, for there are summer courses through NAWA. There's also exchange programs in terms of bilateral cooperation, both for students and scientists. And there's also a program called Poland, My First Choice. This sounds like a song or something, right? Poland, my first choice, my first love. But it's specifically for master's students if they want to come and study. And on the other hand, NAWA also has ample opportunities for exchanges in terms of scientists. So if you are a researcher and want to come and visit, depending on discipline, you can see those programs on the right-hand side, but for instance, the ULAM program is natural sciences, and you can come, I think, from a minimum of 2 months up to 12 months, if I remember correctly. And the other thing that NAWA has, which may be of interest, is if you, like me, have applied for Marie Curie, and didn't get it, like so many of us, there is actually a program that if you have received a seal of excellence from Marie Curie, so if you've reached, I think it's, I don't know, is it 85% or something like that? I don't know. So if you've reached that level, but still those people have not given you your funding, you can go to NAWA and you say, I've got a seal of excellence. Can I please do my project at a Polish university? And they will fund you. That's nice, isn't it? Yeah. Thank you, Poland. Poland, my first choice. Okay, okay. But you can see here that there's really quite a lot of opportunities for both short-term visits, also if you want to come longer. It's actually quite, I think, having worked in lots of different places, UK, Canada, Norway, and now Poland. I think it's quite actually a rich landscape for funding. It's good. Now, if we're talking specifically about Adam Mickiewicz University, there's also programs such as Erasmus and Erasmus Plus. It's probably more applicable for European, I think, people. However, we also have internally some programs that are dedicated to international collaboration and exchanges in terms of visits, research visits. So there's opportunities for basically inviting people to come to AMU, but also to going out to other institutions. So there's both internal and external opportunities in terms of research visits. Here on the right-hand side, you can see this is the main university building. So kind of like an old castle building, which is nice. The natural sciences actually have been moved a few years ago to a campus at the northwest side of the city, and it's quite a nice green space, and it's very close to a park, so a natural reserve, which has some meteorite craters, so it's quite picturesque, and lots of woods. You have to be careful not to get run over by wild boars, because there's many of them, but it's a nice setting, I think. Okay, and just to give you a little sense of the structure of the university, so it's the Poznań, Adam Mickiewicz University in Poznań is quite a large institution. We've got about 38,000 students. across many different departments and faculties, and you can see some of the statistics here. But we do have, in terms of facilities, speaking from the kind of natural sciences side, we do have quite a lot of facilities, depending on what you want to do. You're welcome to write to me and I can kind of find out whether we have what you need. But just to give you a few examples, we recently have got an XRF system set up. We got a sedimentology lab. We have a paleontology lab. We have a palynology facilities, biogeochemistry. We also have a radiocarbon lab, which is operating, as well as kind of environmental and sedimentary DNA group that does research. This is really quite varied across geography, geology, and biology. And much of the instruction, so if you want to come and study as a student, much of the instruction is in Polish, but we do have also some more international programs which are held in English. And of these, I just want to mention one that we recently have put together, and that is an MSc in Geohazards and Climate Change, okay, which may be of interest to you and your students. No, it doesn't want to. Okay, and now I will end with why Poznan, okay? Usually people don't know where Poznan is, and they kind of, but I think it is true that it is the hipster underdog, okay? Like this dog here. It's really very vibrant. It's quite a lot of culture there. I think the motto I once read about Poznan is, work hard, play hard, which I think is a good motto to have. It's one of the oldest cities in Poland. It was actually Poland's first capital. And I also think it's one of the friendliest cities in Poland. It's much, much calmer than Warsaw, and it's much nicer than lofty Kraków, I think. But that's probably biased because I was born there. So, and it's quite a nice vibe throughout the city. So I've shown you the kind of center of town with those really nice old buildings, but there's also a river running through it, Warta River, and along there you've got lots of parks, lots of green spaces. You can go kayaking, you can go relax with drinks by the river, and it's very well connected as well. So, and it's got a really nice baked goods. Once a year for St. Martin's Day in November, we have the craze of croissants, which you can see here, which have, I think, one of them, it's probably around like 500 calories. It's got poppy seed and nuts, and there's like a secret recipe, and it's trademarked. It can only be sold in Poznan, so it's really good. But you can only eat one, and then you don't need to eat dinner. But anyway, come and see us, and if you have any questions about Polish funding, opportunities, about the university, write me a message. I'd be happy to answer. Thank you.
Thank you very much. So, does anyone have any questions? No? Okay. Okay.
Thank you. Anna, more than a general question, not really related to Poznan, but you said that if you have a Marie Curie funded and you didn't get the grant, you can still apply for those. What was the name for that?
I think it's NAVA.
NAVA, okay.
Yeah.
But do you have, how many years after can you still apply for that? And second question, do you have to stick to the project that you presented in the Marie Curie?
Mm-hmm. How many years? I don't know. I would like to apply, and it's been 5 years, so I so I think there's some kind of time limit to do that. And in terms of, how much you have to stick to the project, I would think probably it's because you kind of take the project and want to then do it. But you'd have to read the guidelines, and we can have a look at it if you like. Okay. But there's also this Polones Biz fellowship that was on like my second slide, which may also be an opportunity if you want to kind of change the project that wasn't funded, maybe more to kind of a new direction.
Okay.
Yeah.
Thank
Yeah.
you.
Yeah.
Thank you.
Okay. So I think that's it. So we have a little bit of change of plans. So we will have Yvonne Arroyo talk now, and then the coffee break after. And then after the coffee break, we come back here for the final remarks. So now we have Yvonne Arroyo from the Universidad of Costa Rica with exchange opportunities with the Red Sismológica Nacional.
Thank you. So, good afternoon, everyone. My name is, as she already said, is Yvonne Arroyo, and I'm the current coordinator of the seismic network of the National Seismological Network of Costa Rica, of the University of Costa Rica. Together with my colleague, Leopold Linkimer, we oversee or we perform the seismological tasks of this network. So we mainly do passive seismic. So today I would like to introduce you to our work, to give an overview, and in hopes of finding mutual possibilities of collaboration. This is a photo of the lab. The seismic lab is located here at the School of Geology, and I've heard that some of you may want to visit us, so you are pretty welcome. We are very close. Adiós. ¿Cómo se pasa? A la derecha. Compu. So, then first a little bit of history. I promise as briefly. So our history, the history of a network, starts with the creation of the School of Geology in 1967. I always say it's 76. 67. By the beginning of the 70s, the seismic lab was already established, and there were some instruments already operating, as well as at the Costa Rica Institute of Electricity. So by the 82, both institutions, University of Costa Rica and the Costa Rican Institute of Electricity, decided to cooperate, and the RSN, the National Seismological Network, was born. So another milestones in our history, in the year 91 to 92, we changed from analog to digital recording, and also very important, in 2009, there was a new law of the country which provided us with funds, and then it was possible to expand our network and to improve our technology in general. And also very important, 2019, the RSN is a research program of the University of Costa Rica. And also we cannot talk about seismology or volcanology without a little bit of tectonics. And I can tell you that tectonics in this corner of the world is very complex. For starters, we have 4 tectonic plates interacting: the Caribbean plate, the Cocos plate, the Nazca plate, and the Panama plate. The Cocos plate subducts beneath the Caribbean, and the Panama plates along the Middle America Trench. And we also have this transform fault, the Panama fracture zone, which is very, very active, seismically speaking, and is the limit between the Cocos plate and the Nazca plate in this part. And we also have the Cocos Ridge. The Cocos Ridge is a trace of a hotspot of the Galapagos hotspot. And it goes all the way, this 2,000 kilometers, reaching southeastern Costa Rica. And all this, okay, the Cocos Plate has all these changes, this variation in structure, in the thickness of the oceanic crust, and it changes rapidly. In a matter of 400, 500 kilometers, we have 3 domains, very different. We go from a smooth seafloor segment subducting beneath the Nicoya Peninsula to Seamount province, which has been, the seamounts have been mentioned before by my colleagues in these other presentations. And we go to the presence of the Cocos Ridge. For example, the thickness of the oceanic crust changes from 5 to 6 kilometers to 20 kilometers, the modified oceanic crust in front of subducting in front of southeastern Costa Rica. And this is what makes Costa Rica, this is not only this, but geologically speaking, this makes Costa Rica very special. It has been the focus, this region, Nicaragua, Costa Rica, has been the focus of, since decades, since the 70s, since the 80s, of a lot of research, onshore and offshore research, because these special characteristics so allow us, or allow people to study all the impact of these differences on the formation of the upper plates, and on the seismicity of the upper plate and interplate, and other characteristics. So, and to study all this seismicity, all these active tectonics provide us with a lot of earthquakes, and as my colleague Lepo likes to say, this is like Disneyland for seismologists. We have a lot of earthquakes because of these 4 tectonic plates, and we have 2 or 3 more tectonic blocks also interacting. And here I show you, again, this is the Nicoya Peninsula, Osa Peninsula. This square is San Jose, where we are right now. I want you to notice that we are living, or at least I'm living, we are right now at a tectonic boundary. So San Jose is located in a tectonic boundary between the Panama and the Caribbean plates. Here we show the damaging earthquakes in green since 1821. And 1821 was the year that we got independent from Spain, just to put a date somewhere. To give you an idea, since 1821, we have experienced almost 70 damaging earthquakes. It's like 1 every 3 years. 20 earthquakes with a magnitude of 7 or more. That is like a rough statistics, like 1 every 10 years. People in Costa Rica report that they felt an earthquake around 800 per year. So 8 per month, 2 per week. But these numbers may increase because now we use other channels to communicate with people. So social media and applications. And then people, now it's easier for people to communicate that, to tell us they felt an earthquake. We also experience around 12 earthquakes with magnitudes 5 to 5.9 every year, and at least 1 earthquake with magnitude 6 to 6.9 every 3 years. To give you an idea, I was looking for comparisons. Costa Rica is the size of 2 times Sicily, just to give you an idea of the size of our problems. The number of fatalities related to seismology or to earthquakes is about 800. The worst disaster remains an earthquake that happened in 1910, caused by an active fault. And so it produced almost 700 fatalities, and mainly also related to the construction techniques of the time. And to study, to collect all these earthquakes, we're very ambitious. We have never enough seismometers. At present, this is our network in yellow. We receive here at the Seismic Lab in the School of Geology, we receive the real-time signal of almost 250 stations, and from them, 170 stations are our stations. And at UCR, at the University of Costa Rica, we operate 122. I think there are more now. This is like 1 year ago. and 48 by EASY. These are examples of the equipment we have. Yeah, as I said, you can see the whole country. So this is a big operation. We need to visit regularly these stations. I take the chance to thank Jean-Paul. This is our senior technician at the National Network. Excellent job. I also wanted to point out that we operate the only seismic station above or on the Cocos Plate, and it operates here at the Cocos Island. This involves also a lot of administration. Our seismic catalog comprises at the moment 153,000 earthquakes. This is just like 10 years of this catalog. And we have a magnitude of completeness of 5. That means no earthquake of magnitude 5 or more had escaped us, so we got it, and it's in our catalog since 75, and magnitude 3 since 95, and probably we have to make the estimations again, but probably we are now 2.5 or something like this. The catalog has 500 earthquakes with magnitude 5 to 5.9, and almost 30 with magnitude 6 to 6.9. And it includes 4 earthquakes with magnitude 7 or more. The more recent was the Nicoya or Mare earthquake in 2012 with a magnitude of 7.6. This is, let me see, yeah. This is like a 3D view of some years of the catalog, and as an example of how beautiful we can see the Cocos slab subducting beneath the country, with the deepest earthquake in the north and the shallower in the, okay, we see here the central part of the country with a different subduction angle, and the lowest, the less deeper earthquakes, the shallower earthquakes, are located in southeast Costa Rica. And in volcanology, we also do research and monitoring in volcanology. And we want to study the active volcanoes of the country, from magma generation to the eruptions, and going through the internal dynamic processes of fluid circulation, the eruptive dynamics interaction or possible interactions between tectonics and volcanic activity. And the ultimate goal is to reach or to contribute to an adequate volcanic risk management. We have special seismic stations in these volcanoes and surveillance cameras at Poás, Turrialba, and Rincón de la Vieja. This here is an example of the beautiful Poás volcano. So if you haven't been there and you have some days to spare, and just please go to the Poás volcano, because as you see, it's really beautiful. It's my favorite volcano. It's very close to San Jose. There is, at the School of Geology, there's a geochemistry lab. And we are working together with National University on a monitoring system, automatic monitoring system, using volcanic seismic signals. And since 5 decades or maybe more, staff from the School of Geology and Emerson have been working on physical volcanology and drawing risk maps. Outreach, social outreach, is a very important part of our work. We have a web page, and we have channels, accounts in Facebook, Twitter, YouTube, and with thousands of followers. We now are starting also with TikTok and Instagram, because we have younger people in the lab, and they tell me that nobody uses Facebook anymore. And we, since 2018, we have an app. So we were also trying some citizens science. So some years ago, 55% of people in Costa Rica use Facebook. Some posts may reach 1 million users. And we make daily updates in social media, 10 posts per day. For example, the contents are earthquake and volcanic reports, educational notes, in geosciences. but it has to be attractive, of course, to people to call your attention. We want also to remind people, not only inform about recent earthquakes, also historic earthquakes. Really? Oh, okay. And so that they don't forget. We also made campaigns of volcanic activity, earthquakes, women in science, talks for TV channels, news media, journalists, and we receive also visits in the lab, not only students, but all kind of people that want to visit that have to call first, of course. So we do earthquake location in report since 1976, and we publish a bulletin since then every month. So we're still publishing. We are very proud of this also. So when an earthquake happens and is widely felt, so we publish a little message there, like, people, where did you feel it? How did you feel it? Tell us about it. While the systems, the automatic systems then perform on automatic locations, and 5 to 20 minutes after the happening of the occurrence of the earthquake, then an analyst already review the location. The main objective of earthquake recording is for research purposes, but we also like to inform people as an additional project. I don't have time, but if you visit the lab and I'm there, then I can explain you about our app. These are the emojis. We use these emojis like to make it attractive to people, and we never want to reach these these faces there. So with all the information people give us, and you can see it in the app also, a map with the emojis and with the intensity, and we can, in a matter of minutes, then calculate an intensity map. The research areas. Currently, our staff, we are researching in active faulting in the upper plate through seismicity, remote imaging, field work, INSAR analysis for upper crustal deformation, for earthquakes, faulting, volcanic and geothermal fields, subduction zone structure through tomography, local earthquake tomography. And we are now going through a revision and maintenance and update of our seismic catalog. We have collaborations within the University of Costa Rica, with the Research Institute of Geological Sciences of the School of Geology, with the Seismic Engineering Lab, and the Structural Models Lab of the University of Costa Rica, with the School of Topography. Within Costa Rica, with the Costa Rican Institute of Electricity, the National University, the National Geographic Institute, and with several institutes internationally. In the USA, in Europe, and also with Central American countries. So to summarize, in these 3 domains, which are the main domains where the University of Costa Rica is active, in teaching, our staff participate or guide research thesis, the licenciatura thesis that Marco mentioned this morning. We give lectures here at the School of Geology, and we have, very important, we have student assistants. And I think almost everybody that started in seismology and volcanology in this country was once an assistant in our lab and student, like myself. We have research projects, as I said, in seismology, neotectonics, seismic hazard, volcanology, geophysical exploration. We have this seismic catalog, and we do earthquake and volcanic monitoring, and social outreach, I already mentioned, and I forgot to mention, we are part of the we're advisors to the Emergency Response Commission of Costa Rica. Yeah.
Thank you very much for the presentation. Does anyone have any questions?
Thanks very much for this information. Actually, tomorrow I'm planning to go to the Poa volcano, so
Yes.
it was a
Yes,
nice
do
introduction
that.
to that.
It's beautiful.
And I was curious, for me, coming from a place where there is no almost active tectonic, so it's curious to see how a country which has such active tectonics is living with it, how you are coping with these continuous earthquakes and rifts. So, you have to learn to do that. And I'm wondering how the building, because I saw that actually in the area where we are is one of the most active ones in terms of earthquakes. So I was wondering if the building of the city is actually ready for that, or it is a strict normative, whether this actually is
is followed or not? What's the situation? Let's hope. No, yeah, excellent questions. How we live with earthquakes? Yes, I think it's part of of how we are the Costa Ricans. Everybody has a story about an earthquake. Or did you remember where were you in 1991 if you were born, or in 2012? Or yeah, so we live with this since very early. We experience earthquakes, and in the schools, I don't think that there is really is included in the educational programs in primary school, but I think every primary school performs like drills or they know what to do. Then since 5-6 years, the the National Commission for Emergencies also advertises and conducts national drilling for the earthquake evacuation. And then every year in August, so at least we get through media and through the news, remember what you have to do. And the first thing to do is to keep calm. So if you are experiencing a strong shaking, you just stay where you are, except, of course, that someone is going to fall on you, so you just move a little bit. But don't run, don't rush, try to stay calm. And then, of course, then we have a seismic codes in the 70s, and it's obligatory for the construction firms to follow these rules. And we have experienced some shaking in San Jose, and there has been some damage, but nothing horrible yet. I mean, we know there are some faults crossing the city, but we need to study more about these faults. The seismic engineering lab, they are going through the city, making an inventory of what kind of buildings and what will happen with this shaking, with this intensity. And so we're like slowly preparing for living with earthquakes.
Thanks very much.
I just wanted to mention, sorry. I had more slides, but I wanted to mention that because Costa Rica had these special characteristics about the subducting plate, as I told you. So we have had decades of research, and there are kilometers of seismic lines, active lines reflection, wide angle. We have had also amphibious, so ocean bottom seismometers. There's an inventory of seeping of methane seeps, of faults, of seamounts subducting and conducts where the gases and fluids come out. So it's a great place for research. There's a strong platform already, so we can go into details. Thank you.
Thank you very much. So now we can go to the coffee break, 20 minutes, and then we will meet back here for the final remarks.
No sé.
Okay, welcome back. This is the last part of this workshop. Before to say goodbye and all the thanks, we want to open like a 10-15 minutes for the people who wants to talk about their research centers or their universities. So we will start with Jorge Cortez. He will present us a little bit about CIMAR, is another center at the University of Costa Rica.
Thank you. I apologize because my colleague couldn't come. So I'm going to just mention briefly about the Marine Science and Limnology Research Center. So limnology, for you don't know, that's freshwater systems. So the center, the center was created in 1979, and the idea of these research centers at the University of Costa Rica is to bring people from many different schools and faculties around a central topic. So there's one on natural products, one on genetics, one on history, and this one is related to aquatic science, so we have people from physics, chemistry, biology, geology, and even from the social science that are interested on the marine science topics. Our main offices are here on the campus, and people say, why a marine center in the middle of the country? It's a very small country. In a couple hours, we're on the Caribbean, and in other hours, we're on the Pacific side. So it's easier to move from here to all the rest of the country than being just on one side on the Caribbean. It will be very hard to go all the way out to the other side, to the Pacific. So that's, and there are far more facilities here in San Jose than on the field. And yeah, we have small boat that we use. Many times we rent boats and do a lot of work on diving and coral reef, do work on mangrove, seagrasses, chemistry, physics, and then in freshwater, work on lakes, rivers, reservoirs, and many different topics around that. And that's like a timeline that was a couple years ago when we celebrated our 40th anniversary, created in 1979. And I started there as a student and then became a professor, worked there for 41 years, but still continue collaborating. And there being some highlights there, the publications, we push a lot of that everything be published, which is one of the problems that we have here, that it's a lot of research is being done, but that final very difficult step of publishing is not done. So we really stress that, and we have published several books and compilations about the country. And so there are opportunities there also that you saw for same ones as for the university, but then here we have a lot of programs. We had received students from all over the world, many students from Europe that come to do the field work with us, and then they go back to the universities, whatever it is, to finish their degree. So you're welcome to CIMAR, and if you have any questions, just contact me. Thank you.
Okay, if somebody had a question about the CIMAR, or we will continue. Thank you so much. If somebody also online will be to presenting something, just tell us. I don't know if some other one wants to present something about their universities. Okay, so I think we finish right now. So we want to have some words from the other people of organizers. Renata.
And Katerina. Come up. Oh, later. We share this. Of course. We said one word each.
Okay.
Thank you for coming here. No, yeah. Well, I want to thank the committee. We are supposed to be advisors, senior advisor of this committee, but they don't need very much advisor, basically. No, they are very good. They did all this job, especially in finding funding to support the students to come. So thanks to Inqua first, and also all the other people that contribute with grant for the students. Thank you to them to make this meeting possible. Thank you very much to the local, because the local also did an important help, starting from the head of the school, but also our technician here that has been spending 3 days full time. It's been really great. Well, if you want to add something,
continue?
yeah,
I
definitely,
continue?
yes.
So, I want to thank also the photographer that was really active. Yeah. And yeah, the people from the coffee break, they give us the coffee break, and so everybody, the Escuela de Centro America de Geologia, don't know if the pronunciation is good, but and all the University of Costa Rica. And yeah, I'm happy to be here, to stay here. Thank you, Viviana. Thank you, Karen. You did a really great job. And well, what say next? See you next time.
We actually decide that in a short time we're going to stop to study the Arctic.
Yeah, the polar area in
the
general.
polar areas, and especially after today's presentation,
Yeah.
we thought that Maldives,
Panama.
Costa Rica, Panama, and there are a better place to finish our career. But actually, our career, both careers, start in the Mediterranean.
Yes, exactly.
And in some stage, we say, you know, we should go back to the different climate now.
Warmer climate, yeah. So, yeah.
So, nothing more else.
No. So,
girls.
Thank you so much. Okay, I just want to say thank you to everybody who was involved during this workshop. To Maricruz and Laura, who works with us with the registration and everything else. The people who help us with the chairs, and also and especially with all the talks, the presenters. So thank you so much to everybody.
Thank you. Keep in touch with all our social pages, with the mailing list, and you will hear very soon from us again, because the first Inqua Mare workshop, is going to happen. So thank you. And now we can go for the campus tour.